In this video, I'll be giving you a very quick introduction into some stoichiometry calculations involving concepts like moles, molar mass, and mass. And it's just a very quick beginner guide. So this is one important triangle that anyone should remember when doing stoichiometry, and it tells you the relationships between the three concepts, mass, moles, and molar mass. So how this triangle works is that, let's say we want to calculate the mass, right? So the mass is on top, and what we're left with, because we're trying to calculate mass, so we erase it here, we're left with number of moles and molar mass. So because they're both in the bottom, so the mass equals to the number of moles times the molar mass. So that is what mass is. Mass is number of moles times molar mass. That's the first concept. And the second concept is, let's say we want to calculate moles, right? So this one. So we erase moles because we're trying to calculate for that. And what we're left with is mass and molar mass. So since one's on top, one's on the bottom, it's going to be division. So it's mass of the substance divided by the molar mass. So that's for the number of moles. And lastly is for the molar mass. So similar to moles, right, we're going to erase it here because we were trying to calculate for this. We're left with mass of substance and the number of moles. Since mass is on top, moles is in the bottom, it's division. So the molar mass equals to the mass of the substance divided by the number of moles. So that's how you use a triangle, and you should remember all those formulas I've just mentioned. Moving on, we have our first problem here, which is to calculate the molar mass of CH4 or methane. And to do this, we need a periodic table. We don't need the formulas yet, basically, because we're going to just take the molar mass here from the table. And so CH4 can be divided into two parts, right? There's one carbon, because there's one C, it's basically C1, plus there are four hydrogens, right? H4, so 4H. So this is how you break down a compound. So we have one carbon and we have four hydrogens in this methane. And to find the molar mass of this compound, it's simple. We have one carbon, we have four hydrogen. From the periodic table, we can get, to make things simple, we can get the average weight, or the weight of a single carbon atom. So let's find carbon in this table here. Carbon is right here, right? This is carbon. And the weight of one individual carbon atom is written down in the periodic table, which is on the top right here, 12.011. So one carbon, so there's one carbon, and this carbon weighs 12.011. So it's 1 times 12.011. After that, we add it with the hydrogens. There are four hydrogens, and each hydrogen, if we locate it here, hydrogen, weighs 1.008. So since we have four hydrogens, it's logical, right, to multiply it with 1.008 because there's four. So 4 times 1.088, because one hydrogen weighs 1.008. We do this, so we have 12.11 plus around 4.04, and we get the answer as 16.05. So that's how you calculate the molar mass, or the molecular weight, of CH4. Our second question is to calculate the number of moles of magnesium atoms in 10 grams of magnesium. So let's highlight the important parts here. So it's asking us to calculate the number of moles of magnesium in 10 grams of magnesium. So what can we get from this question? Firstly, it's asking us to find the number of moles, N, of magnesium. So that's a that's the molecular compound we're focusing on, so Mg. And 10 grams of magnesium. 10 grams, right? Grams is weight, mass. So this is the mass. So if we look at this triangle, we have mass. We do not have molar mass yet, and we don't have moles, but it's asking us to find the number of moles. So again, we're trying to calculate the number of moles, so we erase moles. And to calculate moles, it's mass of the substance divided by molar mass. So N is the abbreviation for moles, equals to mass divided by molar mass. MR, which is the abbreviation for molecular mass. And we have mass here. And how do we get moles? 10 grams of magnesium. We get it using the periodic table like before, right? So let's find magnesium, which is right here. And we know that one magnesium atom weighs 24.305 from here, right? 24.305. So 24.305. And what's the units for molar mass? It's grams per mole. Per mole, right? Divided by mole, so mole -1. And you cancel out grams. You're left with, well, it's just to visualize it, you're left with 10 divided by 24.305, 1 over mole, right? And 1 over mole, this is the same thing as 10 divided by 24.305 divided by mole, right? And if you remember your fraction rules or whatever, this is, you could put on the top, right? Because this is basically fraction divided by another fraction, mole divided by 1, like that. So it equals to 10 24.305 mole. So this is just a visualization of how you get moles from dividing mass by molar mass. But anyhow, so you do this, 10 divided by 24.305, and you get the answer is 0.411. Try it and you'll get 0.411 mole. So that is it for this problem. And lastly is the sample problem relating to mass. So let's read the problem. It's calculate the mass of 0.388 mole of CH3COOH. So it's asking us to find the mass. It gives us the moles and the compound we're looking for, which is CH3COOH. Now, to find the mass, right, it's this here. So we raise that. To find mass, it's number of moles times molar mass. So we have the moles here, which is easy, right? So let's write that down here. Mass equals to moles times MR, which equals to 0.3800 times MR. But how do we get the MR of CH3COOH? Because you won't find that here, right? It's a compound now. It's not a single atom, and it's easy. So let's just write down CH3 here, COOH. So let's break this compound down. How many C's do we have? We have 1, 2. So we have 2 C's. And how many H's do we have? We have 1, 2, right? So we have 4 hydrogens, so 2 carbons for hydrogens. And how many oxygens do we have? We have 1, and we have 2. So 2O. And to find the individual molecular masses of these atoms, you apply the same principle as before that we did here. So 2 carbon equals to 2 times the weight of a single carbon atom, which we can get from the table, which is 12.01. Right? And then we have 4 hydrogens, so it's 4 times the weight of 1 hydrogen atom, which is 1.008, or let's make it 1.01 to make things simple. And we have 2 oxygens, so it's 2 oxygens times the weight of 1 oxygen. Oxygens here, and we find that 1 oxygen atom weighs 15.99, or let's say 16. And so this CH3COOH contains all of this, and so if we sum this up, so we do 2 times 12, which let's make it 24. Make things simple. 4 times 1.01, basically 4, plus 2 times 16 is 32, right? So now it's 24 plus 4 plus 32. So 24 plus 4 is 28. 28 plus 32 is 60. This is an approximation, but very close. So the molecular weight of this CH3COH compound is 60. So it's just 0.38 here times 60, which should equal to this, 22.82 grams. And again, if you want to see how the units cancel out, we have 0.3800 moles times the molar mass, which is 60 grams per mole. Let's make this right. So moles, we're left with grams. That's why it is calculating the mass. So that's it for this video. If you have any questions, you can always ask me in the comment section below. Thank you.